Good morning, everyone.
Good morning.
Good morning. Today, an exciting thing is going to happen, and we're taking a field trip to Egypt.
Yay.
So, I went there actually last year, before we're gonna have, so that when we go to the field trip this year, that we'll know everything about the pyramids. Egypt is all about the pyramids and the gorgeous structures. So, I measured last year all the sides and angles of these pyramids. There are different types of pyramids in Egypt. Something that looks like this, this, and this. Now, let's look at this. This pyramid, something looks very right. This just looks like a great triangle, a great pyramid. And I found that all of the sides are equal. They're all 100 feet. Now, I measured the angles, and surprisingly, they're all equal as well. Wow, isn't that weird? So, scientists and mathematicians call this type of triangle an equilateral triangle. Equilateral. Now, what's specific about equilateral? Or what can you find in this word equilateral? That's right, equal, right? Equilateral. Now, everything is equal in the equilateral triangle. Wow, that's easy. Now, we go to the second triangle. Now, the second triangle, what do you see?
It's taller than the first one.
Oh, it is taller. Oh, wow. Yeah, so I measured these, and it seems like their sides are 150 feet, which is much longer than this 100 feet here. But now,
Bottom's smaller. The bottom's smaller.
Yeah, the bottom is smaller. Wow. And I measured it, and it comes out that it's only 30 feet compared to 100 feet over here. So this is very tall, lanky, and we call this, because it has two sides that are the same, but the third isn't the same, we call that, mathematicians and scientists call that, isosceles triangle. Now, I don't know how many of you took Greek, which is probably not likely, but iso means equal. And celes means legs. So equal legs. Now, what looks like legs here?
The two long sides.
Yeah, so these two sides are equal. That's why the Greeks called it isosceles, and why we today call it the isosceles. Now, we learned equilateral and isosceles. 3 equal sides. This one has 3 equal angles. 1, 2, 3. Now this one, I measured the angles as well, and has 2 equal angles of 80. What's the third side?
20.
20, yes. Now the third side is not the same as the 2 different angles.
Smaller.
Yes, it is a smaller angle. Yes. And that's incredible. If you have 2 same sides, then you're going to have 2 same angles.
Why are the angles bigger than the other one on the bottom?
Wow. Angles are bigger because when the legs are longer, that means this side has to stretch more, right? It has to stretch to get to that height and the length. That's why the side that's opposing it, see, this angle is pointing at this side. It's longer than this because the side, it doesn't have to stretch as much here to become 30 feet. Now, you can think about it that way and see why the angles are bigger. Now, the third triangle, I measured it, and nothing is similar. Nothing is the same. 50 feet, 100 feet, 120 feet. Nothing is the same. And I found that the angles aren't the same either. Now, this is a really cool pattern we're seeing here. Yeah. So, this the scientists call a scalene. Scalene. And it means that nothing is similar to each other, and nothing is right. Equilateral. Equilateral. Equal everything. The sides are equal, 3 angles are equal, everything is equal. Equilateral. Isosceles. Isosceles. Iso, same, celes, legs. Same legs. Isosceles, same legs. Scalene, I don't know. What is this word, scalene? Scalene? You don't know. Nobody knows what that word is. Oh, it must mean that we don't know any of the sides, if they're equal or not. Nothing is equal. That's why it's called scalene. You don't know what scalene is. Nothing's same.